two projects. In this video, we are going to explain about the project title AlzheimerNet, an effective deep learning based proposition for Alzheimer's disease stages classification from functional brain changes in magnetic resonance images. Before diving into the execution, let me give you an overview of the project. Let us first understand what Alzheimer's disease is. Alzheimer's disease is a brain condition that gradually decreases memory and thinking skills, eventually impacting day to day functioning. Significant memory concerns, SMC, one of the early indicators of Alzheimer's disease, may also be an indication of mild cognitive impairment, MCI. Since Alzheimer's disease has no known cure and treatment simply delays the disease progression, an accurate diagnosis is essential. However, evaluating a variety of medical data is necessary for Alzheimer's disease diagnosis, which burdens medical professionals. The project aims to develop a deep learning system that accurately classifies Alzheimer's disease stages using functional brain changes observed in MRI scans, addressing the need for early diagnosis and personalized treatment to enhance patient outcomes. Traditional methods for diagnosing Alzheimer's disease, like clinical assessments, neuropsychological testing, medical history review, physical examination, brain imaging, and biomarker analysis, are essential for evaluating cognitive function and detecting brain changes. Yet, they are limited in sensitivity for early detection, accessibility, and distinguishing Alzheimer's from other conditions. To overcome these limitations, in the base paper, the author has proposed a combination of deep learning models, including ResNet 50, VGG16, MobileNet V2, AlexNet, and Inception V3, with a modified version of Inception V3 tailored for Alzheimer's disease stage classification from functional magnetic resonance imaging fMRI data. To further enhance the performance, we have proposed exception and DenseNet models for classification. The system predicts various stages of Alzheimer's disease based on functional brain changes observed in MRI scans, ranging from normal to impaired cognitive function. The project benefits patients, healthcare professionals, researchers, caregivers, families, and society by improving Alzheimer's disease diagnosis and management through accurate prediction of disease stages from MRI images. This increases patient outcomes, support caregivers, advances research, and benefits society as a whole by reducing the burden of Alzheimer's and improving public health. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, databases SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms built in the project. These are the algorithms which are proposed in the base paper, which are ResNet 50, VGG16, MobileNet V2, AlexNet, Inception V3, and AlzheimerNet, which is modified Inception V3 with different optimization. And these are the algorithms which we have proposed to further improve the performance for detecting Alzheimer's disease stages. We have built all these algorithms to compare the performance with different evaluation metrics like accuracy, precision, recall, and FN score. And here, exception model outperformed the other algorithms, and that is the reason we have deployed it in the front end. Let me explain you what exception is. Exception is a deep learning technique. It's known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the images separately. This is called depthwise convolution. Then it combines these parts to understand how they relate to each other. This is called pointwise convolution. This helps exception to understand images better and pick up on important details. One of its strengths is that it's really efficient at doing this, which is important when we are dealing with lots of images, like in medical analysis. Plus, it's great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other data sets before being used for a specific task. That is transfer learning. This makes it super adaptable and useful for projects like detecting Alzheimer's disease stages from medical images. Now let us execute the project. To execute this project, first we need to open the code folder which contains the project source code files. This is the dataset folder. In this project, we have utilized any dataset, which is Alzheimer's Disease Neuroimaging Initiative dataset. We have considered the MRI images from the EDNI dataset. These MRI images are employed for the development and evaluation of deep learning models aimed at diagnosing Alzheimer's disease stages based on neuroimaging data. So here in this folder, we are having two more folders named test and train. In the test folder, we are having the 5 different classes of Alzheimer's disease, which are Alzheimer's disease, CN, which is cognitively normal, EMCI, which is early mild cognitive impairment, and LMCI, which is late mild cognitive impairment, and MCI, which is mild cognitive impairment. So these are the 5 different stages of the Alzheimer's disease. So in the AD folder, we have the MRI images showing brain scans of individuals diagnosed with Alzheimer's disease. And all these images are used to test the performance. And in the CN folder, we have the MRI images showing brain scans of individuals who are cognitively normal without any signs of Alzheimer's disease or cognitive impairment. And here in the EMCI folder, we have the MRI images showing brain scans of individuals in the early stages of mild cognitive impairment. And here in the LMCI folder, we have the MRI images showing brain scans of individuals in the later stages of mild cognitive impairment. All these images are used to test the performance. And in the MCI folder, we have the MRI images showing brain scans of individuals with mild cognitive impairment, which is a transitional stage between normal aging and most severe cognitive decline. So all these images are used to test the performance. And here in the train folder, we again have the 5 stages of the Alzheimer's disease. In the AD folder, we have the MRI images showing brain scans of individuals diagnosed with Alzheimer's disease. And all these images are used to train the models. Similarly, in the CN folder, we have the MRI images showing brain scans of individuals who are cognitively normal without any signs of Alzheimer's disease or cognitive impairment. And in the EMCI folder, we have the MRI images showing brain scans of individuals in the early stages of mild cognitive impairment. And in the LMCI folder, we have the MRI images showing brain scans of individuals with the later stages of mild cognitive impairment. And in the MCI folder, we have the MRI images showing brain scans of individuals with mild cognitive impairment, which is a transitional stage between normal aging and most severe cognitive decline. All these images are used to train the models. This is the sample folder in which we have the test cases for each of the stages. So here again, in the AD folder, we have the test cases for Alzheimer's disease. And here in the CN folder, we have the MRI images showing brain scans of individuals who are cognitively normal without any signs of Alzheimer's disease or cognitive impairment. All these images are used during the execution in the front end. And again, in the EMCI folder, we have the MRI images showing brain scans of individuals in the early stages of mild cognitive impairment. And here in the LMCI folder, we have the MRI images showing brain scans of individuals in the later stages of mild cognitive impairment. And here in the MCI folder, we have the MRI images showing brain scans of individuals with mild cognitive impairment, which is a transitional stage between normal aging and most severe cognitive decline. And these images are the test cases which are used during the execution. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered, so click on login here. So here we need to enter the username and the password, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the MRI scans, and after uploading the MRI images, the application will predict the Alzheimer's disease stages. So click on choose file. So here from the sample dataset folder, that is from the test cases, from the Alzheimer's disease folder, I am selecting the first image. Now click on open. So here we can see that the image is loaded. Now click on upload button. This is the uploaded image and it is predicted as AD, that is Alzheimer's disease. So this person is having the Alzheimer's disease. Now click on try again. Let us upload some more images. Click on choose file. So from the test cases folder, from the CN folder, let us upload this image. Click on open. Now click on upload button. So this is the uploaded image and it is predicted as CN, that is cognitively normal. So individuals in this stage typically exhibit no significant cognitive decline compared to age matched peers. Their memory, thinking, and reasoning abilities are within the normal range for their age and educational level. Brain imaging, such as MRI scans, show no significant abnormalities associated with Alzheimer's disease or other forms of cognitive impairment. Let us upload some more images. Click on try again. Click on choose file. So again from the test cases folder, let me upload this image from the EMCI folder. Click on open. Now click on upload button. So here, this is the uploaded image and it is predicted as EMCI, that is early mild cognitive impairment. So this stage is characterized by subtle cognitive changes that are greater than expected for an individual's age and education level, but do not significantly interfere with daily functioning. Common symptoms include mild forgetfulness, difficulty finding words, or trouble with tasks that require attention or organization. Click on try again. Let us upload some more images. Click on choose file. From the test cases folder, from the LMCI folder, I'm uploading this image. Click on open. Now click on upload button. So here, this is the uploaded image and it is predicted as LMCI, which is late mild cognitive impairment. In this stage, cognitive decline becomes more noticeable and may begin to impact daily activities. Symptoms include more frequent memory lapses, difficulty with problem solving or decision making, and challenges with tasks that require complex thinking. So, brain imaging, MRI scans show further progression of brain atrophy and other changes associated with Alzheimer's disease or cognitive impairment. Let us upload some more images. Click on try again. Choose file. So, from the test cases folder itself, from the MCI folder, I'm selecting this image. Click on open. Now, click on upload button. So this is the uploaded image and it is predicted as MCI, that is mild cognitive impairment. So mild cognitive impairment, MCI, is a broad term encompassing various stages of cognitive decline that are more severe than typical age related changes but not yet meeting Alzheimer's for dementia. Individuals with MCI experience more pronounced memory problems, language difficulties, and changes in reasoning or judgment. While some individuals with MCI may eventually progress to Alzheimer's disease, leading to form of dementia. Others may remain stable or even return to normal cognitive impairment. Let us upload some more images. Click on try again. Click on choose file. Now let us upload the images from the test data set itself. So I'm selecting this image from the AD folder. Click on open. Now click on upload button. This is the uploaded image and it is predicted as Alzheimer's disease. Click on try again. Let us upload some more images. Click on choose file. From the test cases folder, I'm uploading this image from the CN. Click on upload. So this is the uploaded image and it is predicted as CN, that is cognitively normal. Let us upload some more images. Choose file. So from the MCI folder, I'm selecting this image. Click on open. So this is the uploaded image and it is predicted as mild cognitive impairment. In this way, just by uploading the MRI brain scans, we can predict the Alzheimer's disease stages. Now click on graph link here. So here we have the loss in accuracy curve of exception. So here for every increasing epoch, loss is decreasing in both training and validation. And here for every increasing epoch, accuracy is increasing in both training and validation. And here we have the comparison graphs for the evaluation metrics: accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis we have accuracy score and on the y-axis we have algorithm name. Accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. This is the precision comparison graph. Here on the x-axis we have precision score and on the y-axis we have algorithm name. Precision is a measure of the correctness of positive predictions made by a classifier. This is the recall comparison graph. Here on the x-axis we have recall score and on the y-axis we have algorithm name. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a data set. This is FN comparison graph. Here on the x-axis we have FN score and on the y-axis we have algorithm name. FN score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. The algorithm which is performing best will be used for prediction. In this case, exception model outperforms the other models, and that is the reason we have deployed exception in the front end. Now click on sign out button here. So in this project, we have built various deep learning models for Alzheimer's disease stages classification from functional brain changes in magnetic resonance images. Leveraging EDNI dataset, which is Alzheimer's disease neuroimaging initiative dataset. And we have identified exception as the best performing model. So we have deployed it in the front end and we have tested the system. So this project enables early detection for Alzheimer's disease.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.